The volume of a rectangular prism can be found by filling it with cubes or using the formula volume is length times width times height. What are the volumes of these rectangular prisms? So volume is, starting with the purple one here, 1.5 times 2 times 2.5. I then converted them into equivalent fractions, and knowing that 1 and 1/2 is the same as 3 copies of a half, and 2.5 is the same as 5 copies of a half. So I could multiply more easily. So when I multiply, we get 30/4 or 7.5. On the right, we have the volume of a half times 4 times 1, which is 2 times 1, which is also 2 inches cubed. So notice then I also put in the inches cubed over here. We are in volume, and because we're multiplying inches times inches times inches, we're multiplying it 3 times, our volume is then represented in cubes, so inches cubed, whereas area is in squares. A net is another way of representing a three-dimensional figure. A net allows us to see all of the faces of the figure at once. Let's learn to draw the nets of the following figures. So we'll start with the pyramid here, the square pyramid. So we're going to first draw the polygon base, which is a square. And then you're going to draw one triangular face on each side of the polygon base. And you want to check these sides here to make sure that they are congruent. So when we fold them up to create the pyramid top, that they are able to connect with one another. Similarly, with the rectangular pyramid, we'll draw the rectangular base. We will draw a triangular face on each of the polygon bases. And notice that because of the length of here, that our triangles will be slightly different. So, but we still need to make sure that these sides here are congruent. So when we fold them up, they will meet. Okay, then we have the rectangular prism. So we will draw the rectangular prism base here. We will draw one rectangular face connected to each side of the polygon base, here, 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 and here. Check the rectangular sides to make sure these are congruent. So these cutout pieces, and then draw the second polygon base connected to one of the rectangles. And it says connected to one because you could have connected it to the top here, the side, or the bottom. Similarly, with the pentagonal prism, and it's a pentagonal prism because we have a pentagon, and it's a prism, not a pyramid, because it doesn't meet at one point like the pyramids do. So we'll draw the polygon base of the pentagon. We will draw a rectangular face connected to each side of the polygon base. And then we check to make sure that the rectangular sides where those arrows are will meet together, are congruent. And then we need to draw the second polygon base connected to one of the rectangles. I don't have it drawn here, but you would also need to create a pentagon off of one of these here, so that when you fold it, we'll have a top. Which of the three-dimensional figures is represented in the net shown? Is it a triangular pyramid, a rectangular pyramid, triangular prism, hexagonal pyramid, hexagonal prism, octagonal pyramid, or an octagonal prism? It is a hexagonal pyramid. We have a hexagon in the middle, or as our polygon, and if we were to fold these all together, it would come up to one point, so it's a pyramid. Which three-dimensional figure is represented by the net shown? Is it a triangular pyramid, a rectangular pyramid, a rectangular prism, or a triangular prism? This is a rectangular prism. I would fold each piece of these up and then this part would snap down and match here, and this part would match down here. So it creates a nice prism, but it shouldn't be a rectangular prism. No, it would be a triangular prism. So we need to not highlight this one. Perfect. Triangular prism. Fill in the blanks. An octagonal prism has how many bases and how many faces? A rectangular prism has how many faces that are what shape? An octagonal prism has two bases. The bases are each octagons, and we would need 8 faces to finish them, one for each side of the octagon. A rectangular prism has rectangular faces that are rectangles. One sheet of poster board measures 18 by 24 inches. How many sheets should Mr. Nelson buy so that all 5 teams of students can build one of each figure? We're going to decompose each one of our shapes so that we can find the total area or surface area that each net consists of. So I'll start with the rectangular prism here. We have 4.5 by 2 to get this space here, which is 9 square inches. We have another one of those at the top, so 4.5 by 2. We have 2 that are 4.5 by 6, so 4.5 by 6, 4.5 by 6. We have one that is a 2 by 6, and another one that is a 2 by 6. So all together, when we add these, we have 96 square inches. Let's move to the triangular prism. We have 2 triangles and we have 4 rectangles. So if we start with the triangles, the area of a triangle is half times base times height. So half times the base of 4 times the height of 3.5, which is 7. We have 2 triangles, so I wrote that one twice. Then we have a 4 by 6.5, another 4 by 6.5, and the middle is a 4 by 6.5. So this one is 92 square inches. And then we have the square pyramid. We'll start with the square in the middle, which is 7 by 7. And then we have 4 triangles surrounding our square. So half times 7 times 7. And 3 more of them. So altogether, this square pyramid is 147 square inches. Altogether, then, we have a total of 96 plus 92 plus 144 for 335 square inches. Well, we have 5 teams, so we need to multiply their areas by 5 teams. So we need 1,675 square inches. The poster area given up above is 18 by 24, so that is 432 square inches. So we'll take how many total that we need divided by the poster area. So we have about 3.87 blah, blah, blah sheets of poster board, which we'll round to 4 just to make sure. So each team will need 4 sheets of poster board. Select the formulas needed to find the surface area of each 3-dimensional figure. You may select one or both formulas. Take a moment to pause the video and we'll talk about the results. So a cube has all 4 sides, which are a square or a rectangle. So we would only need base times height. If we have a rectangular prism, we would also only need a base times a height because all of our sides would be squares or rectangles. When I look at a triangular pyramid, we would need the area of a triangle formula. And I have a picture on the right here. So it's a triangular pyramid because the triangular part tells us that it's a triangle base. And a pyramid means that they're all going to meet at one particular point. So all we have are triangles versus a square pyramid where we would need both. So our base is a square, but notice that we would need triangles in order to make the pyramid portion. And then a triangular prism, we would need both of them because we would have three rectangles and then 2 triangles for the bases. Homework. You're going to print the homework file included in the practice problems homework Dropbox. Complete the problems as outlined within the homework pages, taking care to show all of your work and all of your steps. Scan and upload your documents back into the practice problems Dropbox.